Okay, so we're going to learn about area, right? 3.3.2. Okay, so I will cut it short. The theory part, okay? So theory part, how to get the formula of integration to find an area under the curve. So you just need to know, okay? If you want to determine the region from area under the curve, let's say this is fx, okay? So I want to determine the area of A from A to B, the lower limit, okay, the lower limit, then upper limit. The lower limit is from A to B, okay? So the area of A can be determined by using integration from integrate from for fx with respect of dx from A to B, right? Right. And then one more thing you need to know is that this is a formula. Later on we will use it. Then you will know how to use it. And then you have to remember that if this is a curve, and then I want to find the area from A to B, B to C, C to D. Okay, we have to find it separately. And remember, the area is always positive. So area above, right, above the x-axis, above this line, okay, above this line, okay. So if this is the curve, so this is positive, the yellow part is positive, and the blue part is negative. So therefore, when you find the area of the shaded region, okay, so we have to find separately. That is from B to A, fx dx, and then modulus B from B to C, fx dx plus C from C to D, fx dx. So this is, you must use modulus this part because the value is negative here, right? So the positive plus modulus it will become positive. Anything you modulus become positive. So if I said this is modulus, the value here is positive, then you plus positive, positive, then you get your correct answer. Okay. So, okay. So if you want to find the area, okay, area of the region, okay, just now is dx, the area of the curve and the bounded by the area of the curve and bounded by the y-axis, okay, let me repeat. And this is the area bounded by the curve and the x-axis. So you remember, if bounded by the curve and the axis, x-axis, then you use dx, fx dx. If the curve is bounded, area is bounded by the curve and the y-axis like this, then we use dy. Okay, so you use dy. So in this case, we also can write a to b x dy or a to b fy dy. Okay, so we integrate with respect to y. Okay, and then as same as area bounded by the curve and the x-axis, right? If x-axis, so still remember, if x-axis with the curve is, there are two parts like this. Okay, so above the x-axis positive, below the x-axis negative. But for y like this, so on the right is positive, right is positive, and left is negative, right? Left is negative. All right. Okay, so when you want to find these two areas, so remember is area of A from B, Fy dx, right? And plus BC Fy dx. Sorry, this one is wrong. Huh? Okay, so this one should be Fy dy, Fy dy. Okay, so the most important thing is here is if this negative, then when you integrate, you must put modulus. Right? So this part is modulus. Huh? B to C, right? Okay, so B to C, right? You modulus it, Fy dy. Okay, so and you modulus again. Okay, okay, so please correct it. This one is dy dy. Huh? All right, so let's see how to solve. Okay, the first one is in this type. There is question number 9. All right, so in example, all right, so given the area of the shaded region A is 10 unit, so here is 10. Okay, 10 unit. This B is 6 unit. So if the question asks you to find the area to determine the integration, the value of integration from B to C, so B to C, so the answer is -6, but the area is positive. The area must be positive, always positive, okay? But the answer for the value of integration can be negative, so remember. All right, so then from A to C, so A to C, so A to C is A plus B, right? So the value of A plus the value of B. Okay, but remember is 10 plus, okay, is 10 minus 6 is 4. Okay, so 10 minus 6 is 4. Right? How to get this is the area from A to B, Fx dx, and then you plus the area from B to C, Fx dx. So this part is 10, then this is minus 6, negative 6. So therefore you get 4 here. So if you modulus like this, the modulus, then A to B is 10, then you plus modulus -6. All right, then you get 10 plus 6 equals to 16. So you have to differentiate between area, the value of area, and the value of integration. Okay, so it's a bit different. You have to refer to the graph also. If the graph, the area is under the x-axis, then you put -6 if we want to find the value of integration. Right? But the area under the graph, under the x-axis, right? So if given the value of integration is -6, you have to change into positive, right? So remember. So let's see how to solve. You can try by yourself. So this is 4.5. All right, so from -2 to 7 is add unit. So -2 to 7 is add unit. So the daughter is add unit. That's mean I want to find 3 to 7. So 7 -2 Fx dx is equivalent to -2 to 3 Fx dx, and then plus 3 to 7 Fx dx. So we substitute the value in. All right, so this is 8. Okay, this is 8, and this is -4.5. So plus 7, 3 to 7 Fx dx. So therefore, our value is, right, the total value is 37, fx dx is 12.5. So here is 12.5. If there's any mistake, let's see. Right now, okay. Then this part is negative 4.5, okay. Negative 4.5. So total area of P and Q, that is 4.5. 4.5. And then you plus 12.5. Okay, so you get 17. All right, 17 unit square. All right, let me check. Did I type wrongly? Okay. All right. I think there's something wrong with the question. So as actually you don't need to put a unit square here, huh? Because this is not an area, right? All right. So this is the answer. So we go back to B. Okay, B, you can solve by yourself. So you need to understand the value lah, huh? Find the area of the H. Okay, so B, right? Right, to double check, huh? Okay. So the value of H, so is part, huh? But this is given as negative 4 to 0 fx dx equal to 6 is actually this area. Okay, so this area is negative 4 to 0 fx dx. So it is equivalent to 6. So how to find h then? So the h, okay, so h will be total area, the rectangle area. Okay, you minus the area like this, right? Okay, the yellow part that I already just shaded. Okay, so meaning that is 3 times 4, and then you minus 6, so is 6 also. So this part is also 6. This is 6. So how about the area of the K? The area of the K, so this one is from 0 to 2 fx dx. So this one is equivalent to 5. So the area of K is 5. Hence, the question asks you from negative 4 to 2. So you need to separate into 2 fx dx plus 2 to, okay, 0 to 2 fx dx. Hence, we will get 6 plus 5, so equivalent to 11, right? 6 plus 5 equivalent to 11. All right. Then we go to C. All right, C, area of the shaded area of the Q is 18. So this is 18. So how to find the area of P? So how to find the area of P? Okay, this is Fy. So area of P is quite simple. So you just find the total area, right? This area, and then you minus by this area. So is 5 times 5, area of the rectangle. Okay, so it's square actually, 5 times 5. Then you minus this above the upper part of 18. So you minus 18. So you get 25 minus 18. is 7, correct? 7 plus 13, 35. So express the area of Q in the integration notation. Therefore, areas of area of Q, express area of Q. So this is area of Q. Okay, area of Q or area of P? Let me check. Area of Q. So area of Q in terms of notation, right? So integration notation. So you look at the x, the function given is x fy. So x fy, therefore, we use the area of the curve, the area under the bounded by the curve is and y-axis. Okay, so therefore is we integrate from 1 to 5, then x dy, or 1 from to 5 fy dy. That is number 2. So this part is this. So it's 1 5 fy dy. That is C. Okay, so this is actually using the knowledge you have learned previous week, right? Okay, is this actually is this the 5 rules of function fx dx, but now is transformed into area. Okay, so now we go to the next one. Find the area of each of the regions. Okay, so find the area of here. So you can see here. Okay, still remember this is x-axis. So this part is negative. This is positive. So and then we need to find what is the value of intercept here. Okay, so we have to solve it first. So equals to let it become 0 because x-axis y is 0. Okay, therefore you get x squared minus 2x equals to 0. So x times x minus 2 equals to 0. So x equal to 0 or 2. Therefore here is 0. This is 2. Okay, now we can find the area of the shaded region. The area is separate into 2 parts. So A and B, right? Okay, so the area is A plus B. Okay, so you have the modulus, remember, 0 to 2. And then y dx, right? So y dx, I straight away use y dx. So it's x squared minus 2x dx. And then you plus 2 to 3 x squared minus 2x dx. Okay. Oops, not enough space. So I will do it this part. Okay. So the area, you modulus. So you modulus become, okay, let me see, x squared minus 2x. So x squared, so x cubed over 3 minus 2x squared over 2. And then you integrate from 0 to 2, right? 0 to 2. 0 to 2. Then you plus. Okay, so now I know this is x cubed, the same thing. So minus x squared, you integrate from 2 to 3. So you substitute the value in. Okay, 2 cubed over 3 minus 2 square. Okay, so and then you minus 0. Then plus. Okay, this one no need modulus. But if you use modulus, also no harm. Okay, so here you get 3 cubed over 3 minus 3 square minus 2 cubed over 3 minus 2 square. Okay, so this one you will get 8 over 3 minus 4. Okay. All right, so you get 8 over 3 minus 4. Okay, so you get negative 4 over 3. Okay, plus this is 3 cubed over 3, that is 9. So my 9 minus 9 is 0. Okay, and then you minus this one, as this is the same, right? So this negative 4 over 3. Therefore, is you get 8 over 3, right? Because this is 4 over 3 plus 4 over 3. So you get 8 over 3 for example, okay? For A, so A, again, I want to find the area of this red region, okay? Shaded region is bounded by the curve from 0 to B. So you need to find what is B lah. So what to do? So we let y as 0. So remember y as 0. So is 2 plus x minus x squared equals to 0. So x squared minus x minus 2 equals to 0. So you use your calculator, you will get x minus 2, x plus 1 equals to 0. Therefore, x equal to negative 1 and 2. So here is negative 1, this is 2. So we want to find this area. So we integrate from 0 to 2. Okay, 0 to 2. Y dx, right? So it's actually 0 to 2, then 2 plus x minus x squared dx. Okay, all right, so we integrate. So you get 2x plus x squared over 2 minus x cubed over 3, okay, from 0 to 2. Okay, you substitute in, so it's 2 times 2 plus 2 squared over 2 minus 8 over 3. Then you minus 0, okay? Okay, when you get 0, this one is quite simple. If 0, this one, everything is 0. So we just put a 0 to represent the value, the overall value. So here will be 4 plus 2, 6, okay? 6 minus 8 over 3. Okay, so you get 13, 6, 3, 18, 18 minus 8 over 3, you get 10 over 3, or 3, 2 over 3. Okay, that is the value. Then we have another question, B. So this is 1, 1, and 3, 1 over 9, okay? So we want to integrate the area. So under the curve, okay? Okay, under the curve, and bounded by under the curve and the x-axis, okay? So this area, so how to find? So it's from 1 to 3. And then 1 over x squared dx. So it's actually like 1 to 3, then x power negative 2 dx. Okay, so when you integrate, you get negative 2 plus 1 over negative 2 plus 1. And then you substitute the value. So before that, we simplify first. So you get negative 1 over x. Then from 3 to 1. So you substitute in the value. So you get negative 1 over 3 minus negative 1 over 1. So it's 1 minus 1 over 3. So you get 2 over 3. That is your answer, right? So the next one. Okay, so this one is, there are two regions. There is A and B. So this part, you remember, you need to modulus. Okay, so because this is the value here is always less than 0. This value always bigger than 0 when you integrate. So what we do, right? So we modulus. All right, let's. Okay, modulus. So it's from negative. All right, sorry, -1 to 0, and it's x. All right, so this one is, all right. So if you, this one we put it first. Then plus from 0 to 2, x times x plus 1, 2 minus x dx. So you expand. So this one you expand. So you get x 2, right? 2x. And then you get negative x squared. Then you plus 2. And then you minus x. Right? At the end, you get x times x minus x squared plus 2. So eventually you get negative x cubed plus x squared plus 2x. Okay, so all right, so before we can integrate, we have to change into expansion form. Right, so it's a bit tedious. So what to do? Okay, so it's quite long, the process. Okay, so we integrate, therefore you get negative x over power 4 over 4 plus x cubed over 3 plus x squared, and then from 0, -1 to 0, so you modulus it, plus this one is the same thing, so you just copy. Okay, so substitute the value in. So modulus, you get 0 minus -1 over 4 minus, sorry, plus 1 over 3 plus 1. Okay, modulus, then plus, okay, negative 2 to the power 4 over 4 plus 8 over 3, because 2 cubed is 8, then plus 2 squared is 4, then you minus 0 again. So if we use calculator, right, so is for 1 over 12, so it's negative 1 over 12. All right, let me see, check that. Negative 1 over 4. So it's 4 over, okay, never mind, we do it step by step. Okay, you get 0 minus negative 1 over 4 plus 4 over 3. Right, so here you get 16 divided by 4 is negative 4 plus 4 plus 8 over 3, then minus 0. So they will get 8 over 3 here. So this one, if you use calculator, it will be 3. This one will be 4, 4, 16. Okay, let me see. Oh, I made a mistake here. Okay, I made a mistake here. Here also a mistake. No, correct, this one. This one is correct, but here is wrong. -1/4. So because -1 cube is negative, so -1/3. Okay, so that's why I see some, when you are experienced, then you know that something is wrong when you want to do. That's why I hesitate for a while. So this part you get 7/12, right? So minus 7/12. So you get negative, you get 5/12. So you will get -5/12. Okay, -5/12. And then you plus 8/3. Okay, so no modulus. So at the end, you'll get your answer. So 8/3 plus 5/12. So you get 3 1/12 or 7/12. Right? So this is C. So you can try D and E, right, by yourself. D and E by yourself. Right, so this is the answer here is 10, 1/6. Okay, so answer for E is 4 minus x squared. So the answer here is 13. All right, so remember for E, you need to find out what is these two. So these two, you just use 4x squared equals to 0. So x squared equals to 4. Then x equals to positive, negative, square root 4. That is positive, negative 2, right? Therefore, this is -2. This is 2, right? So when you solve, you want to find these two area. Okay, so remember you need to modulus the whole area. Okay, so therefore it's -3, -2, and then 4 minus x squared dx, and then you plus the modulus from 2 to 4. Okay, 2 to 4 with x, right? Something wrong. Okay, you should do it by yourself, but okay, 4 minus x squared dx. All right, so you can do it by yourself. So you continue it later on. Okay, and then this one, what is this? So from here equal to 0, you will get x equals to -2 and 3. Therefore, this is -2 and 3. But we want to find these two area only. So if you say this A, this is B, so how? So you got 1 to 3. Okay, what dx, and then plus. All right, so B is, remember, below is negative, right? Above is positive. Therefore, you need to use modulus. So modulus from 3 to 4. So what dx? So you find out. The answer is already given to you. Okay. Now we go to find the area of the curve between the area of the curve and the y-axis, meaning the area bounded by the curve and the y-axis. So remember, this is Fy dy. Okay. So how to solve? Okay. So remember, if the area bounded by the curve and the y-axis, so you get AB, right? X dy, right? Or Fy dy. Okay. So first question. So where is my A? All right, where is my A? Oh, my A is gone. So good. You will do it by yourself. Also, A is here. B is here. Where is C? Okay, so C. So this is, sorry, this is C. So you see, you do it by yourself. Okay, y equals to 4x square, right? So it sums up like this. Okay, so this one you refer to your text, your workbook. I just sketch this out so that you know what it's going to do. This is C actually. So this is 4x square y. Okay, so you're going to do this question by yourself. So the answer I give you is 2 square root 2. All right. So now I want to show this question first. So how to find? Okay, so you see that is already given y minus 3 square plus 2. So we want to find this area. So therefore is 1 to 4. Then we have to check again. On the right is positive, on the left is negative. So here is positive, so no need to use modulus. So you use this formula. Then you have y minus 3 square plus 2 dy. Okay, then this one you can expand. For 1, you expand is x squared minus 6y, y squared minus 6y plus 9 plus 2 dy. Okay, hence you will get y squared minus 6y plus 11 dy. All right, so then you can integrate, you get y cubed over 3 minus 6y squared over 2. Okay, 6y squared over 2 minus 11y from 1 to 4. Okay, now we can substitute the value in. So it's 4 cubed over 3 minus 3 times 6 divided by 2 is 3, right? 3y squared, so 3 4 squared, 11 times 4. Okay, and then you minus 1 over 3 minus 3 minus 11. Okay. All right, so you'll get your answer. All right, so 64 over 3 minus 48 minus 40. Sorry, for minus. Sorry, is the plus. Here, plus. Okay. And people always big mistake. I'll say 11y. So 11 times 4, okay. So we double check. So your answer is 9 here. Okay. So this is how you find the area of the shaded region or between the curve and the y-axis. Okay, we go to B. B is A. This is A. This is B. So you can do it by yourself. So remember to check. Okay, this is positive, negative. So here is -1, 0. What is this? So you can solve this, equal to 0. So now x is 0. So x is 0. So you get y times y minus 4 is 0. So y is 0 or 4. So here is 4. So you can solve this. Okay, you can solve this. Okay, so here is -1 to 0. And then y squared minus 4y dy. Okay, so remember the formula for area under the curve and the y-axis is x dy. Okay, so we substitute in. Then you remember to put modulus from 0 to 4. And then y squared minus 4y dy. Okay, so then you can do integration. So you get y cubed over 3 minus 2y squared from 0, -1 to 0, and then plus the same thing, but you remember to put modulus. Okay, from 0 to 4 modulus. Okay. All right. So you substitute in the value. So the first thing you get here is 0. Then you minus. You get negative 1 over 3. And then minus 2. Okay. And then plus modulus. So 4 is 4 cubed over 3 minus 2 times 4 squared. Okay, minus 0. Okay, so if you use your calculator, again, you will get 13. All right, 13. Okay, so this part is negative lah. Negative 48 minus 16, 32, right? 32, negative 32 plus 4 cubes, right? 4 cube. Huh? This is 4 cube. All right, maybe 4 cube, right? So it's 64 over 3 minus 32, right? Okay, then we come to this question. This question is very interesting. So how to find? So this one, when you integrate, so it's actually, it will find this part only. So meaning that when you integrate 1 to 4, all right, x dy, okay, is actually integrate one part only. Okay, therefore you have to, if you want to find the area of the shaded region, you must times 2, right? From 1 to 4 x dy. Okay, why like that? Because every time we integrate, it's only area under the curve and the y-axis. Okay. Okay, so 2, and then this one is 1 to 4, right? If y equal to x cubed, x squared, that means x equals to y 1 over 2. So we have y to the power 1 over 2 dy. So this one 2, and then y 1 over 2 plus 1 over 1 over 2 plus 1. Okay, and then this one 4, 1 to 4. Okay, so therefore you may substitute in. So you will get, not yet, before that you will get y 3 over 2. This one is 3 over 2 also, therefore it's 2 over 3. Then 4, 1 to 4. Okay, then you can substitute the value in. There is 4 over 3, so you take out 4 over 3, then you substitute 4, 3 over 2. Okay, and then minus 1 over, sorry, 1 only, yeah. 1. So this is a bracket. So you get your answer. Okay, for square root of 4 is 2, 2 to the power 3 is 8. Correct? All right. 8 over 3, sorry. 8, right? Okay, sorry, 2 to the power 3, 8 minus 1 is 7. Okay, so therefore 4 over 3 times 7, so you get 28 over 3. So this is the answer. All right. So, okay. So this is area, very simple, area between the curve and the y-axis. Okay. All right, now we go to area between two curve and, or area between a curve and a straight line. So the first thing is very simple. If you see this type area of the shaded region is this part, then we minus fx minus gx. The above minus the below, and from A to B. Okay. If you have this right? So the formula for this is we integrate from a to b from fx minus gx, that is above minus below. So if you have this type, let's say I have another type is like this and like this. I want to find this area. Okay. So is this will be your f, this will be your g. This is above, this is below. All right. So straight line minus the curve. Now is the curve minus straight line. Huh? And then you have, if you have this situation, a straight line and a curve and not intersect each other, so we have to separate into two, right? That is the straight line, this the straight line, okay? From A to B is straight line, gx, and then plus B to C is fx. So this is separate, right? This is the area between the curve and the y-axis. Oh, it's the same thing. Huh? So this is the curve is above. This is curve above. And then this one is below. So therefore it's x1 minus x2 or fy minus gy from A to B if they are perpendicular or they intersect each other. If not, it will be like this. So this is this part will be A and this part will be B. A will use A to B for the curve and then B to C for the straight line, right? So straight line you can use, usually you can use area of triangle or area of rectangle. Okay, let's see. For between the two curve, so between the two curve, so is A and B, so is just fx minus gx if intersect each other like this, right? And then also if like this, so you want to find the area with respect to the y-axis, then is fy minus gy, above minus below, right? Okay, now we go for the example. Okay, this one is curve and the line given. Okay, what else here? Okay, area and the curve given, right? All right, so let's see how to do. So so equation or straight line given is yx plus 3. What is c and d? So we need to find the first thing, what is point coordinate a and b, right? So the difficult part here is to find the intersection point between a and b. So here is straight line minus the curve, right? So if we put y1, y2, okay? So meaning that we want to find this area is c to d, then is y1 minus y2 dx. Okay, so before that, we want to find what is the coordinate of A and B. Right, so therefore is y1 equals to y2. Why y1 equals to y2? Because at A, the coordinate y must be equal. Right, and coordinate B, the coordinate y also equal, x also equal lah. So, but easier to solve by using equal the y1 because no need to change anything. So that's therefore is x plus 3 equals to x squared minus 3x plus 6. So you get x squared minus 4x. So everything on the left, you move to the right. Huh? Okay. Make it bigger. So this one equal to, okay, not yet. Okay, you move and then 6 minus 3 is plus 3. Therefore, we have x minus 1, x minus 3 equals to 0. Therefore, x equals to 1 and 3. So here is 1 and 3. So do you need to find the y-intercept, the y value? If the question didn't ask you to find the coordinate A and B, then you no need to find the value of y. But in case you want to find the coordinate of A, therefore when you x is 1, y is 3, then your y will be, you use this, right? 1 plus 3 is 4, and then 3 plus 3 is 6. Therefore, our A is 1, 4, and our B is 3, 6. Okay, so here is 1, 4, 3, 6. Okay, now we can solve. We can find the area of the shaded region. All right, so is from 1 to 3, and then y1 minus y2, right? y1 minus y2. Therefore, x plus 3 minus x squared minus 3x plus 6 dx. Okay, so you put in, you simplify, you get negative x squared, right? X plus become plus 4x, and then 3 minus 6, you get minus 3 dx. All right, then you integrate, therefore you get negative x cubed over 3 plus 2x squared minus 3x from 1 to 3. So substitute the value in. So negative 3 cubed over 3 plus 2 times 3 squared minus 3 times 3. Then you minus a negative 1 over 3 plus 2 minus 3. So you get your value. So your value should be, you see, according to the textbook, is 4 over 3. All right. Sorry, according to the workbook is 4 over 3. Okay. Okay. All right, you can check that. So, all right. So now we go to A. Okay, A. So A is C. You want to find the area here between the curve and the x-axis. So there is no intersection between the straight line and the curve, right? Because here we don't need the straight line. Okay, you want to do it also on, okay, never mind. Okay, we have to separate into two, A and B. So you need to know what is this. So again, all right, again, we equal the y value. That means you get x squared plus 1 equals to negative x plus 3. Therefore, you get x squared plus x and then minus 2 equals to 0. Okay, 1 minus 3 is 2 minus 2. So then you get x, all right. 1 is plus 2, then minus 1. So therefore, x equals to 1 or negative 2. So this part is 1. Okay. Then this intersection point, that is your x-axis. So y equals to negative x plus 3. So y-axis, x-axis, y is 0. Okay, so therefore x equals to 3. So this is 3. So this one we use, you can use the area of triangle. Okay, so therefore we need to find what is y here. How to get y? So y is using this negative 3 plus 3. Get to 3 plus 3. Let me see. Let me check. Sorry, it's not negative 3. So this is 1. Okay. So this is negative 1. So this is 2. So the height is 2, right? So the area of this is 1 over 2, right? Triangle, right? 1 over 2 times 2 times Okay, this difference is 2, so times 2. Therefore, is 2 lah. So now we can find the area of the shaded region. So we separate into 2 parts. Okay, A and B. So A is 0 to 1. Okay, we integrate x squared plus 1 dy, and then you plus b. B is 1 over 2 times 2 times 2. Okay, then you get x cubed over 3 plus x from 1 to 0, and then this one you will get 2. Therefore, you get 1 plus 1 over 3 plus 2, right? So, right, so maybe I have to write properly. So 1 over 1, then minus 0 for this one, and then you plus 2, right? So you get 3, 1 over 3, right? The answer. So 3, 1 over 3 for the area of the shaded region, that is unit square. So this one in exam don't write, you need to know the area. Unit is unit square. So how about this? Okay, you can try to do this question. All right, so this question you can try. B. So the answer is using the curve, the answer is 1 over 3. Very simple. Okay, so first thing, you need to know what is the x value. Okay, either one also can. You use the area of the curve between the curve and the y-axis, or the curve within x-axis also can, right? So, but first thing you need to find what is the intersection point here. So meaning that I substitute the x into y square, therefore equals to y square, right? Y square, x is x square equals, so this is square lah. Is it correct? Yes, okay. Y equals to y to the power 4. Therefore, y to the power 4 minus y equal to 0. So y to the power 3 times y minus 1 equal to 0. So y equal to 0 or 1. So here is 1. So here is 1. Here also 1. Okay? Because y squared is 1, x also 1. Okay? So if y is 1, x 1 square also 1. Right? So now I can find my area of the shaded region. So I use above minus below. Above minus below. So from 0 to 1, above is this one, right? So x equal to y squared. So we need to change into y. So y equals to x 1 over 2. So x to the power 1 over 2 dx. Okay. Oh, sorry. No need to this. Okay, I will write again. This is x to the power 1 over 2 u minus x squared dx. Okay, so you can find the answer. So you integrate 0 to 1. So here is x3 over 2. And then 2 over 3 here. And then this one is x cubed over 3. Right? So you can get the answer. Okay. So this is C, B, right? How about C, right? C, you want to find this area. So you can see here, this is area is triangle. So make our life easier. There is 1 over 2 times 4 times 4, right? Therefore, you get 8 here. So we just need to find this area. So this area is from 0 to 1. Okay. Equation of the curve is x times 1 minus x. Is it correct? Sorry, equation. Right, so this one is, there's something wrong here. Right, so 1 minus x times x plus 4, right? Okay, so we integrate 1 minus x time x plus 4 dx. Okay. Okay, so you 0, 1. So you get negative x squared, and then negative 4x plus x is negative 3x plus 4 dx. All right, so you can integrate yourself from 0 to 1. What is this value? So this is A, this is B. Yeah? A, the area of A is this, the area of B is this. Okay, so you add up A plus B. That is your answer, right? So the answer is 10, 1 over 6. You can check. Okay. Okay. Okay, let me check correct. 4 minus 3x. Right, so we'll get x cubed. Right, so you get the value. So this value plus this value, you get yellow value, that is 10 over 6. So you can try by yourself. Right, so the video for area ended here. Right, please do the exercise in your workbook. Okay.